Ladies and gentlemen, welcome to the very first episode of Things I Wish I Understood Better During My CS Degree, explained with classic memes and vines.
Ladies and gentlemen, welcome to Target!
As always, I'm your host, some dude that was born in the early 2000s, has this extensive knowledge of classic memes and vines, and thought they would never be helpful to his professional capacities. Here to explain to you how to survive college, get through your CS degree, and land a job in our messed up job market.
Ladies
Today's fun and exciting topic is passing by reference or value, living the asterisk ampersanding C++ dream. As a brief example, what do you think of when you hear these words?
LeBron James, LeBron James, LeBron James, LeBron James, LeBron James.
If I had $5 and was a betting man, I'd say you probably
LeBron
thought of this guy. But what all did you think of? His face? His stats? His team? All from those couple words? How'd you do that? Now there's two methods here. The first is you could have driven from our lovely Weber State all the way out to Akron, Ohio, where the king lives, break into his house, kidnap him, and bring him back so you could personally question him on all of these stats. While that could have worked, instead, I believe you probably heard the words and associated it with all of those facts in your big brain because you're so smart. But what's wild is that all that took was his name. None of his stats or his team had to be talked about for you to pull up all of this information in your head about him. This leads us into our next topic. First topic, really.
E is called internal pointer variable.
Now, I learned about internal pointer variables from this guy, and you get to learn about it from me.
E is called
An internal pointer variable is how we connect an address in memory to an object that's stored in memory from your running program. While a normal variable may have, maybe something along the lines of, let's go integer x is equal to 15, right? That means that x stores the value 15. Instead, what happens with an integer or with an internal pointer variable is that the variable itself stores the address in memory. That's fun. That means that you can take this address, go out to our memory block, find the address, and then you will find the object that it's associated with. That seems a little roundabout, but it's got a lot of really, really helpful things that does. To show you a brief example of how this works, first up top is a declaration of a normal object. Normal class name, obj, that creates a variable of type class name. If you add this little asterisk next to that class declaration, you get a variable of type pointer to a class name object. This will hold the value in, or the address in memory where you can find a class name object. Now you might be wondering, like, how do you get that value? How do you create one of these pointer variables? There's two operators you need to know. The ampersand here is called the address of operator. If you take an existing variable that has an object in it and put something along the lines of, let's say, so again, integer x is equal to 15, and then here you say integer asterisk x is equal to ampersand. Wow, that's awesome. You know what? That's so bad. Okay, well, ampersand x, that is called the address of operator because it's going to grab the address where x is stored and save that into our pointer. Let's name that something else. Let's call that y. So now y stores the address in memory where you can find this integer. Now later on, if we decide we need to pull the value out of y, then we could say, let's just go right back to, let's call integer z is equal to, if we put the asterisk in front of y, of y, not x, that's going to get it's going to dereference y. It's going to tell the system that rather than just using the address, go to that address and give back that what is stored there. So now z would be equal to 15. Now, this is kind of confusing and feels very overcomplicated at first of why you would ever do this. But let's take a quick example. If you have a function, and forgive me, it's been a minute since I've done C++. I do Python now for my job. But if you were to have a function that took in a parameter integer x, and all it did was x plus plus. We have two options here. If that just takes an integer, if I were to call that function with just the number 12, what that does is it creates a brand new integer in memory that then we operate on. But that's not stored anywhere. Even if I say integer x is equal to 12 and then pass that in and then just put in x here, what it does is, if I don't do anything else, it creates an entirely new integer in memory with the number 12, which means that then doing plus plus and making that 13 doesn't matter because we're not looking at that anymore. However, if we then were to make it so we could pass in a pointer to that integer, then this operates it in memory. So when you go out later to access x, it's going to go out to memory. That's what memory looks like apparently if you're ever curious. It's going to find x, it's going to add 1 to it, and then when you go to find that later, you're going to get the new value of 13, not 12. This is called scoping. When you are accessing, or when a function is trying to operate and edit a variable, it most likely doesn't have abilities to do that permission-wise. But if you pass in a reference to it, then it can operate on it. If you are ever coding in Python, this is done automatically for you. Most modern languages do. However, C++ gives you this flexibility so that you can decide how much you need to optimize and make your system more efficient. The other thing I would mention real briefly is that this is an extra speed boost. If you haven't yet, you'll later implement something called a linked list. A linked list is a collection of nodes, so let's call this node 1, and then node 2, node 3. Maybe you've probably worked with arrays and stuff before, but they're not super efficient because you have to have that entire array stored in memory, or stored in that program. What a linked list is that it has a pointer to the next node. Wow, I don't know why it keeps doing those lines. A next node in the sequence. So then all I have to have in the program is node 1. And then I can take its pointer, I can go find its address in memory, and pull in that next node, which would be node 2. Then I can go and find that next pointer and pull in node 3. If you had to store all of the values all together, all you've got is an array. This is so much more efficient and is really powerful memory-wise. With all of that said, I think you're now ready to go and be a pointer and memory wizard. Granted, you're really not ready at all, and I don't think anybody ever is. But go watch the same video I watched before and take these memes and remember that you can do it. If you use pointers, you will be able to access in memory and alter the same thing all over the place without having to have the values all stored in memory. This is really, really valuable for systems that are integrated. Little chips like ones in cars or whatever. If there was any kind of a delay because you had to go and I don't really know if that example is really all what I meant for it to be. But pointers speed up things a lot. It helps you access memory, helps you operate on the same thing, and it is very, very important to operating systems, low-level systems, all of the above. I believe in you. Until next time.